Okay, let's take up some of these homework questions really quickly. So 1C, the two angles. These two angles add up to what? 90. And there's a formal name for it as well. No, it's not a triangle. How is it? Yeah, there's a complementary. Yeah. You remember this word? E or I? E? I? Is it an E or I? Complementary. E? Complementary. Looks right? E? Okay. Whew. Thank you, Annie. All right, so complementary angle. Just like 180, it's supplementary. 90 is called complementary. So it adds up to 90 degrees. So notice here, it's variables. 2x plus x equals 90 degrees. So collect like terms. So 3x equals 90 degrees. X equals 30. Okay. Similarly for this one, supplementary, because it's a straight line that adds up to 180 degrees. So for D, it's going to be x plus 2x plus 30, and it's going to equal 180 degrees because it's a straight line. Straight line adds up to 180 degrees. So collect like terms, 3x plus 30 equals 180. Okay, move that over, move the 30 over. So 3x equals 150. And then divided by 3. So 150 divided by 3, x is 50 degrees. So if I were to ask you what are the angles, this would be 50 degrees. And what would this bigger angle be then? 130, right? Two different ways you could do it. One, sub it in. So 2 times 50 is 100. 100 plus 30 is 130. Another way for you to check, remember, it has to add up to 180. So 50 plus 130, it does give you 180. So you can always check. Right. This one, last one right here, F. So these two angles add up to? What do these two angles add up to? Anybody? 90, good. Right, add up to 90 degrees because of complementary again. Right. So collect like terms. X plus x is 2x. 30 minus 10 is plus 20 degrees. So when you move the 20 over, you get 2x equals 90 minus 20, so 70. And then divided by 2, so x is 35 degrees. Okay. Okay, let's take up this last one right here. So these ones, I think it's pretty straightforward. You should be able to do this, 4C. Okay, so 4C, what is angle A? Anybody? Brianna? 42, how did you know? Perfect. So this is an isosceles triangle right here. So this angle is equal to this angle right here. So that's isosceles. When I came around to look at do homework check, none of you guys wrote the reason in brackets. Okay, so remember, good. You should always write the reason. Okay, since A is 42, that means B is, aren't we? What's B? No, skip. Okay, Pedro? 48, how did you know? It's 90 degrees, so it's complementary. All right. C. 35. How did you get 35? No, this is not a 90-degree angle. Sean?
41 degrees.
41. How did you get 41?
C plus 55 is like, C plus 55 is 96, so you just subtract the 55.
Okay. Yeah, so you know that this is 42, you know that this is 42. So then 180 minus 42 minus 42 minus the 55 gives you this part right here. Okay, yeah, so that one is a little tricky. Okay, so don't assume it's 90 degrees unless you see that 90-degree right angle sign. Okay, and then D. Is this an isosceles triangle? Is this one right here an isosceles? No, so D is not 55. Okay, so again, same reason, sum of a triangle, you know that all the angles have to add up to 180. So if this is 90 degrees right here, 55 degrees here, that means this is 35 degrees. And again, sum of triangle. Okay, so this one was a little tricky. You had to like rotate it, look at it, like tilt your head to look at it. Okay, so when's your test on this? Monday, yeah. Okay, so make sure you can do all these, especially these ones where we took up in class. Okay, moving along, we're gonna do our lesson today on circle properties. More terms for you guys to memorize. Sorry. Okay, yes, spelling does count. Spelling counts. Spelling counts. Okay. So, some of the words you know already, but there are a few new terms that you need to memorize. So, an arc is any word on the circle. Okay. Circumference, you guys know already, is the perimeter of a circle. So this whole thing is called circumference. Radius, half. So from any point on the circle to the center, that's radius. Diameter is the straight line across your center. All right. Secant. Secant is a line that goes through your circle. All right. So what's the difference between a secant and a chord? Difference between this line and this line. Sean? Yep. Yeah, so a chord stops at your circle, but a secant goes on. It goes through it. Okay, so that's the difference between the two. Tangent is a line that touches one point on the circle. Okay. And then we'll get into central angle and then scribe angle in the next one. Okay, we'll get to those ones. So this diagram, you do have to memorize it. I don't need the definition, but I'm gonna tell you on the test. I'm gonna give you guys a circle like this, and you'll have to label it. Okay. So it should be easy marks if you can memorize the terms. It should be easy marks, like 1, 2, 3, 4, 5, 6, 6 points right there. Okay, with no calculation. Okay, so circle properties. So here's one circle property. It's called the tangent radius property. So as we were saying, a line that touches anywhere on the circle, this is called your tangent line. This line right here from your center to a point on the circle, that's your radius. And the angle that they always form is 90 degrees. So I could draw another line like this. Okay, Cindy, you paying attention? Yeah. Okay, because I hear a lot of clicking sound. Okay, I could draw any other tangent with radius, and that's also 90 degrees. Okay, so having said that, what is the angle C right here then? What is this angle? Yep. Sorry? 63. How did you get that? Yeah. Good. Okay, so even though I didn't draw that 90-degree angle, but because of this property, you know that that's 90. So C equals 180 minus 90 minus 27. So that will give you 63 degrees. All right. So similarly for this one, what's angle D? Sorry? 90, yeah. 90 because of the tangent property. E? 44, yeah, because this triangle right here. This is a sum of triangles, so 44 degrees. And then F, if this is 44, this is 25. That means, so let's do a calculator. Let's use a calculator. So 180 minus, oh, sorry. Actually, this triangle. I could just do this triangle. 180 minus 90 minus 25. So F is 65 degrees. Yeah. And you can also check it another way. 65 plus 46 plus the 44 plus 25 should also give you 180. Okay, so that's a nice easy rule. Tangent radius property makes a 90-degree angle. Okay, that's all that property means. Okay, now we get to the more properties. These ones right here are the most important ones. Okay, so make sure you pay like 200% attention to this part. I know the previous ones, the angles that we did, those were easy. But this one, you make sure you're paying attention. These ones right here are called inscribed angles. What are inscribed angles? Any 2 points on the arc. Okay, so this is arc AB. If you connect the 2 points to any other point on the circle, on the circumference, these angles are all the same. And these are called your inscribed angles. Okay, so I could draw another one, like right here, and that angle would be the same. Okay, so any 2 point on the arc, if you draw it to a third point, it always makes the same angle. Okay, and if you and if your arc is the diameter, that angle that it makes, it's 90 degrees. Okay. So if your arc could be this short or your arc could be this long. So if your arc is all the way like this across, like where your diameter is, that angle, that inscribed angle is 90 degrees. Okay, so again, I could draw another one like this, and this is also 90 degrees. Okay, and then this one right here is called a central angle. So if I don't draw it across to the circumference, but I draw it to the center, this is called a central angle, and it's double your inscribed angle. Okay, so here, notice my arc is a concave arc, okay, which is like more than 180 degrees. Same rule applies. So if I draw it to the circumference, that's my inscribed angle. And if I draw it to my center, that's the central angle. And it's double. Okay. So let's try some, let's do a little summary right here. Okay. So if this is 30, what is x? 60, because it's double. Good job. Okay. What about number 2? What is x? 40. That's right, because those are both my inscribed angles. Okay. What about this one? 90, because my arc is my diameter. So my inscribed angle is 90 degrees. Okay. This one we don't really use much, but if you were to extend that line out, you actually make an isosceles triangle, and so that's just 6 centimeters. All right. We don't use this much, so don't worry so much about this. Okay. This one right here, if you have a chord and you draw a line straight down the middle of it, that also makes it 90 degrees. We do a lot of this in grade 10. So this is grade 10. We actually do all the proofs and equation of lines and all that. We prove that. Okay. But for now, you just need to know that your chord and the perpendicular bisector, that's what the name is called, makes a 90 degree and it splits it in half. Right? But this one, again, it's grade 10. Right? This one we just learned about, the tangent radius property. So that angle is also 90 degrees. Okay. Opposite angle in a quadrilateral adds up to 180 degrees. So notice this is not a parallelogram. If it's a parallelogram, they're equal, but it's a quadrilateral inside a circle. So the opposite angle adds up to 180. So what would x be? 100. Okay? Because it adds up to 180. And then the final property, the angle between a chord and a tangent through one of the endpoints of the chord is equal to the angle into the alternate segment. So this one, again, we don't use much. So don't worry about this one. Okay. Even reading this sounds so confusing, so I don't want to confuse you guys. All it means is that this angle is equal to that angle. So it's also 60. But we don't use these two. Okay. So yes, those are a lot of properties, but once you do a couple of examples, it does make sense. Okay. So we can do this page together, and then the next 2 pages would be homework. All right. So I don't know why, but there's a lot of freckles on this page. So what is A right here? 60. Why? What is this angle called? What's the name of it again? Angle A is called? Inscribed. So again, writing that reason in brackets. That's how you remember. Okay, what's B then? 50, yeah. So B is 50 degrees, and because it's also an inscribed angle. Okay, C. What is C? Oh, by the way, this is 25 right here, okay? Okay, what is C? Who says it's 25? Who says it's 50? Okay, I'll give you guys another 10 seconds to think about it. It's either 25 or 50. Think about it. Okay. Let's vote again. Who says C is this angle right here? Who says this angle is 25? Who says it's 50? Wow, I have 10 people in the class. 50. Why is it 50? Yep. Yeah, this is actually your central angle. It's your central angle. Because this is my arc right here. So this is my arc right here. Okay, so drawing a line. So from the arc across to the circumference, this is my inscribed angle. And then drawing the same from the same arc to the center, that's my central angle. Okay, so remember, from the arc to the center, that's central. Central, central, central. Right. Can you guys see it? Like if I turned it like this, is it easier to see? So that's my inscribed, that's my central. Okay, so it was a little tricky. What's D? 90, yeah. Why? Huh? Because that's my diameter, and so this is, what is this angle called? Inscribed. It's my inscribed angle. What is the angle right here? It is an angle. This angle right here, what's that angle? Yep, 180. So you see, it still works. It still applies. If this is 180, half of it is my inscribed angle, which is 90. All right, so the property makes sense. Okay, and then E. What is E? (64). And this is called my central angle. Okay, where's the arc? Right here. Okay, this is my, you can think of it as like the arrow if it helps you see it better. So this is my arc right here. So going across to my circumference, anywhere on the circumference, this is my inscribed angle, 32. So that means this angle here, that's my central angle, which is double, and it's 64. Okay. Try these ones. Take about 10 minutes. 10 minutes, try 3 and 4, and we'll take it up. Okay, I want you guys to try it. Okay, so let's take these up together. So with all of these, the most important is draw the arc first. Draw your arc. So in this case, I'm going to draw my arc right here. All right, that's my arc. That means this point and this point, I'm going to draw it to across to my circumference. So this, I'm going to draw this, which means this is my inscribed angle, 50 degrees. Same arc, drawing a line to across to my circumference. Okay, that means this is also my inscribed angle, and so A is 50 degrees. Good. Okay, this one right here, I have to look for my arc. Now I know some of you drew your arc right here, okay, but if you draw your arc here, you didn't connect it together, so that the two points didn't connect to a point across. So that's not your arc. You want to draw your arc here. Okay, if you draw your arc up here, then these are your A and B points, and then drawing across. So you see how your arc connects to a point across to your circumference. So that's your inscribed angle right there, and then this is also your inscribed angle right here. Okay, and so that means B is 40 degrees. All right, can you see it better now with the color? Okay. C, same thing. I have to find my arc first. So this is not a good arc. because again, it doesn't connect to a point together. So this is one of the arcs. Okay, this right here. Okay, those are my two endpoints of the arc. So when I connect this, okay, so when I connect it, this is my inscribed angle, which is the 50 degrees. And same 2 points, connecting it to this point right here. That means this is also my inscribed angle, so x is 50 degrees. Okay. Similarly, you have another arc over here. Okay, this arc right here, if I draw it across, yeah, so you see, that's why C is 30 degrees. Okay, so you have two sets of inscribed angles here. Okay, so, and this one, here's my arc on the bottom. So what's D? What's this angle then? 35. Good. All right. And similarly, I could draw another arc up here and going across to this way. So Y is 25. Good. All right. E. What is Z? Is that Z? 32. That's right. Because, yeah, degrees. Because my arc is over here. Okay, my arc is sideways over here. This is my inscribed angle. This is my same inscribed angle. Okay, and then E, 45 degrees. Yep, because that arc. So this is 45 degrees. Okay. X. What's X? 90. That's right. Because where's my arc? My arc is all this right here. That's my arc. Okay. So here, let me draw this like this. So my arc, drawing it to a point across. Right here. That's 90 degrees. That's my inscribed angle. And if I draw from the same 2 points of my arc, I draw it across. That means this is also my inscribed angle, which is 90. Okay. And what's F? Okay, how did you get 38? Because that's it.
The line. Wait, so where's the arc is on the other side?
Yeah.
The top is 38.
Yeah.
Also,
so this one is a little hard to see, but yes, your arc is right here. Yeah, the other arc is on this side. Right there. So then this angle and this angle is the same. Okay, so this is an inscribed angle, this is an inscribed angle. It's still like a cross. It's pretty close, but it's still like, any 2 points that any point, any angle that it makes with your arc. Okay. 4. Number 4 is tricky. Okay, Petra, what is X? 20. Okay, so Petra says 20. Now, I know some of you think it's 35. So, which one is it? Who says X is 20 degrees? Who says X is 35 degrees?
Wait, no, whoa.
Okay, so those who said it's 20, why is it 20? Whoa, you guys are so good. How do you guys know? How do you know that this is an isosceles triangle? Yeah. So this is your radius, which means this is also your radius. So if those two are your radius, that means these two lines are the same. So if this is 20, this is 20. So x is 20 degrees. Okay, so this is tricky because I know a lot of people would just think, oh, it's 35 because it's symmetrical. But this is an isosceles triangle because your radius is the same for all your for all your circle, all around the circle. Okay, so then what is D? Ooh, how did you get that, Amy? It's right. How?
No.
You're right. It's 110. But why is it 110? Where did this 110 come from? Sorry? No. Petro? 35 plus 20. What is this whole angle right here? Your inscribed. It's 55 degrees. Your inscribed angle. This is your central angle. So it's double. All right. So your arc is here. All right. If your arc is there, that means this angle, this is your inscribed angle, which makes this your central angle. So if this is 55, then this is 110. Okay. Now that you know this, let's try B. What is x? What is x? 20, because this is your radius, this is your radius. It's an isosceles triangle, so it's 20 degrees. And so y is 80, because that's your central angle. Your inscribed angle is 40 degrees. Double that. This is 80 degrees. Okay. How many of you got A and B? Good job. Okay. It's tricky. Alright, if you didn't get it the first time around, it's okay. We have a few homework questions. You can practice that. Okay. What's the connection between in a quadrilateral with a quadrilateral inside a circle? Adds to 180 degrees. So x is and y is perfect. Yeah, simple as that. Opposite angles add up to 180 inside a circle. And so x is, and y is, that's it. Degrees. Okay. So we learned a lot today on circles, but that's all it is with circles. Circle angles. It was actually like grade 8 and grade 10, but now they put it in grade 9. So there you go. In a new curriculum, you guys need to learn angles in a circle. Okay, so for homework, you guys have a good 20 minutes to finish this up. So no more freckles on the page. Just so only 12 circles. You can finish this in 20 minutes for sure. Okay, so this page, okay? Front and back. So front and back, all the circles. Finish it in the next 20 minutes and then you'll have no homework. Otherwise, finish it up for homework.